So let's talk about one of the biggest challenges in AI right now. How do you teach a machine to actually move, to feel, and to interact with the world around it? We're going to explore that question by looking at the AI Book Hackathon, a project that's all about building that exact kind of intelligence. Let's dive in.
Really think about that for a second. We've got AIs that can write an email or create a stunning image, no problem. But building one that can just walk across a room or pick up a cup or navigate around furniture, that's a whole different ballgame. How do we close that gap between the digital world of code and our physical reality?
Well, that's exactly where the AI Book Hackathon comes in. It's designed to be the perfect starting point to tackle this problem head-on. It gives you a roadmap to mastering the fundamental principles you need to give machines a body and build robots that are truly intelligent. Okay, but before we can build anything, we've got to get on the same page about what we're even talking about. So in our first section, let's break down what physical AI actually means and explore this fascinating intersection of code and reality.
At its heart, physical AI is this incredible meeting point where three huge fields come together: physics, machine learning, and robotics. But the most important part of that definition is the goal: to create embodied intelligence. See, this isn't about some algorithm just running on a server. This is about intelligence that can live inside a physical body and actually act in the world.
You can think of these three fields as the pillars holding the whole thing up. Physics gives you the rule book of the world. Machine learning allows a system to learn and adapt within those rules. And robotics, well, that provides the body to act on all that learning. You absolutely need all three. They're completely interconnected.
All right, so the theory makes sense. But what do you do with it? Where does the rubber meet the road? That's what we're getting into in Section 2. We're going to focus on what matters and take these ideas from just theory to real, tangible applications.
And this really branches out into two main paths. On one hand, you have the incredible frontier of humanoid robotics. This is about tackling the seriously complex challenge of making machines move and act like we do. And on the other hand, you have real-world applications that are making a huge impact right now, from industry and manufacturing to creating life-changing assistive devices in healthcare.
This all sounds fantastic, but how do you actually get started? What are the tools of the trade? And that brings us right to Section 3, your robotics toolkit. We'll look at the essential lessons you need to get up and running. You see, building physical AI requires the right tools. For instance, you need a framework like ROS2, which stands for Robot Operating System. Think of it like Windows or Mac OS, but for robots. It's the standard way to get all the different parts to communicate. Then you need to understand kinematics. That's the math of motion that tells a robot how to move its arm from point A to point B. And maybe most critical of all is physics simulation. This is a total game changer. It lets you crash your virtual robot 1,000 times in a world like Gazebo or Unity without ever breaking an expensive part. It makes development way faster and safer. Now, I know what you're thinking. Learning all of this can seem pretty daunting. But the good news is you're not expected to go it alone. And that leads us to our final section, starting your learning journey with a complete support system designed to help you succeed.
To back you up, there's a whole ecosystem of resources. You get step-by-step tutorials when you're just finding your footing, real-world case studies to see how this stuff is used out in the wild, and tons of practical code examples to dig into. And for those of you who really want to push the envelope, there's even access to key research papers from the field.
Now, as you're learning, you're definitely going to have specific questions pop into your head. Something like, okay, but how does a simulator like Gazebo actually handle the physics? It's a great question. And you're not just expected to Google it and hope for the best. Instead, you get to meet your very own physical AI and humanoid robotics assistant. This thing is trained specifically on ROS2, simulation, and all these advanced topics. You can ask it anything. It's basically like having a personal tutor on call 24/7, ready to help you get unstuck whenever you need it.
So when you put it all together, the core principles, the right toolkit, and a powerful support system, a clear path forward starts to emerge. AI is moving beyond our screens and into our physical world. The future is being built piece by piece, robot by robot. So the only question left is, are you ready to be one of the builders?